To maintain the serene quality of coastal Florida living, homeowners rely on structures that filter the environment without obstructing the view. A high-end pool enclosure is designed to achieve exactly that. However, there is an invisible physical reality to these structures. From a structural engineering perspective, a screen enclosure is essentially a massive aerodynamic sail. During a tropical storm, it captures incoming wind and converts it into extreme physical force. This diagram shows the scale of that threat. Red arrows demonstrate lateral pressure hitting the sidewalls, while blue arrows show resulting uplift forces at the roofline, measuring thousands of pounds during severe weather. Because of these extreme loads, an enclosure cannot be treated as a lightweight backyard accessory. It must be approached as a permanent, survival-rated engineered structure. On a calm afternoon, a cheap retail kit and a custom-engineered enclosure look practically identical to the untrained eye. They both utilize aluminum frames and mesh screens. The difference emerges under exposure C and D wind loads. When the weather turns, a retail kit becomes a catastrophic liability, while a rigorously engineered version remains a permanent asset. This diagnostic matrix outlines exactly where the retail standard fails. We evaluate structural integrity across 4 key metrics: foundation, frame alloy, fasteners, and screen technology. In every category, retail kits take shortcuts that compromise the entire build. Safeguarding a property investment requires looking past the surface aesthetics to understand the invisible structural and chemical differences separating a temporary kit from an engineered baseline. The analysis begins at the base. A common high-failure method for retail kits is to drill standard bolts directly into thin concrete pavers that sit loosely on the soil. This diagram reveals the result. Aerodynamic uplift cracks the concrete paver, pulling the bolt free. By contrast, an engineered structure requires deep, poured concrete footers. Main vertical beams anchor directly into thick, earth-bound columns, securing against extreme uplift. The metal skeleton itself requires a specific grade of alloy. Standard retail kits rely on 6063 T5 aluminum, which lacks the tensile strength for high wind loads. Proper hurricane resistance requires 6005 T5 structural alloy, forged specifically for maximum resistance. Without a high-tensile skeleton rooted into an earth-anchored foundation, the superstructure is compromised long before a storm makes landfall. Even with heavy-duty aluminum and deep footers, structural weight ultimately relies on microscopic points of failure, the individual screws holding the joints together. Technicians drill hundreds of fasteners to lock critical stress points. With standard galvanized screws, galvanic corrosion rapidly destroys the joint. The engineered defense is the Nylo-Tec fastener. Its specialized ceramic-coated seal separates dissimilar metals, halting rust entirely. Preventing microchemical degradation at these joints is the only way to ensure the macrostructural integrity of the enclosure against hurricane-force winds. Another physical reality of residential construction is the pool deck. A properly built deck is never perfectly flat. It has a slight slope to ensure water drains away from the house. DIY kits assume level ground. As this first graphic shows, a perfectly square frame on a sloped deck creates massive foundation gaps. The engineered solution uses industrial 3D lasers to map the exact slope. Every upright beam is custom cut to that angle, creating a zero-gap, flush base. This precision applies to the screen mesh. Amateur fiberglass installation causes uneven tension and dangerous wind flap. Instead, high-visibility MicroMesh must be used. Pulled drum-tight across the frame, it provides maximum debris and wind resistance without blocking the view. Flawless geometric alignment combined with drum-tight tension eliminates vibrating hazards. It transforms the individual components into a unified aerodynamic shield. These strict physical engineering standards directly inform the legal realities of Florida real estate. Under the Florida Building Code, enclosures are permanent structures requiring a 3-stage inspection and a professional engineer's seal. Without it, unpermitted DIY structures explicitly void a homeowner's hurricane coverage. If a collapsed kit damages your roof, you face a total loss with zero insurance reimbursement. This hurricane hierarchy of needs illustrates the correct progression. A proper build starts with a foundation of engineering precision. That precision earns the insurance and permit compliance in the middle layer, which ultimately secures the property's ROI. Attempting to save money at the base engineering level compromises the legal protection and insurance coverage of the entire home. When a home inspector evaluates a property, unpermitted retail kits are immediately flagged as teardown liabilities. A fully engineered permitted structure is recorded as a permanent addition. As noted here, a permitted enclosure physically attached to the property title consistently adds between 5 and 10% to the total home resale value. Choosing the engineered route is a calculated real estate asset generation strategy, depositing directly into the home's equity. To secure a professional consultation, receive a complete wind load calculation, and explore 0% financing options, contact Screen Factory Florida. True peace of mind and maximum property value are achieved only when flawless structural engineering meets rigorous legal compliance.